Hello students, welcome once again to this section. We have a system of equation with three different variables, and then we are to find the sum of s squared plus y squared plus z squared in this case. So let's look at how we can solve this. First of all, since the system of equation, let me call this one equation 1, call this one equation 2, and call this one equation 3, right? Now we are going to use this in two cases to find all possible values of, or find the sum of s squared plus y squared plus z squared. Now in the first case, let me say case 1. In case 1, what I'm going to do is that I'm going to assume that they are all the same, all variables are the same. So variable x is equal to y, same way this is equal to z, right? So if all variables are the same, it means that wherever I see y and I see z, I can put x over there, right? So from equation 1, so let's start this in from equation 1, we have s squared, s cubed, and remember I said x is y and it's also z, so wherever I see y, I replace that one with x, being equal to, I have 4x here, and then I have that to be also x, right? They are all the same, so let me bring them to this side. S squared plus 2x minus 4x and then minus x being equal to 0. So now when we solve this, what are we going to get? We are going to get s cubed. 2x minus 4s is going to give us negative 2x, minus s is going to give us negative 3s equal to 0 in this case, right? So we just have s cubed minus 3x equal to 0. How do we find x? So remember that I have x here and x here. I can factorize them out. So I have x into brackets s squared minus 3 being equal to 0, and then from here x here is equal to 0. So x is equal to 0. That will be the first possible values of s we can get here. And then we have s squared minus 3 equal to 0, and then s squared will be equal to 3 goes to the other side. How do we find x? By putting square root on both sides. 2 will get rid of the square root, and I have x is equal to plus or minus the square root of 3 in this case. So now it means that x will take the component of plus or minus of 3. Now remember that we said in the first case s is equal to y, y equal to x. So if that is the case, then it means that y is equal to z, which everything here is equal to plus or minus 3, which means that y, if s is 3, y is 3, z is 3. If s is negative 3, y is negative 3, z is also negative 3. So if that is the case, then it means that we have our s squared plus y squared plus z squared, which the question is asking us to find. Our s squared, let's say if it is negative or positive, because of this square here, it's just going to make everything to be positive, because if I have negative 3 squared, negative times negative will give me positive. So in this case I have 3 squared plus square root of 3 squared, square root of 3 all squared plus the square root of 3 all square. This will get rid of the square root, 2 will get rid of the square root, same here, and I have 3 plus 3 plus 3, which is just going to give me 9 in this case. So it means that our first part is giving us 9. We had our first part to be 0 here, the second part is also giving us 0, right? Now let's look at the other case. Now this is a case where, so we call this one case 2. This is a case where we have our x being equal to y, but our z is different, right? They are not equal to that. So if that is the case, let's we are still using equation 1. So in equation 1, we are, remember case 2, s equals to y. So it means that wherever we see y, we are still making it to be x. So plus 2, so this y changes to x, and then equal to what? Our 4x. But we are saying that z is different, so z will not be equal to x. So we are just going to maintain our z in this case. So we have s cubed plus 2x. We are sending this to the other side, minus s being equal to z. So we have s cubed 2s minus 4s is going to give us minus 2s being equal to z, and therefore z will be equal to s cubed minus 2x. We are going to call this one equation 4, right? So we have our equation 4. Now let's take the second case. In equation 2, we are still assuming, because we want to get another component of z so that we can solve that system of equation to get the possible values of x again. So we'll consider equation 2, but the case still remains the same. Wherever we see x is y, but z is different, so we will not touch z. So we have y cubed, which is just s cubed, and then plus 2z equals to y here with x, and then we have plus x here. So it means that our 2z here will be equal to, what is 4x plus x? That will be 5x, and this goes to the other side. I have minus 3x in this case, right? And with this one, I'm going to call this one equation 5 in this case, right? Now, so we have two system of equation with components of z and x, right? How do we solve this so that we can just get rid of one of the component, which is z? So you remember that I have 2z and I have z here. If I decide to add them, I'm going to get 3z, which is not going to work. But if I subtract them, I'm still going to get, I'll get one of the z. But the best thing is that I'm going to multiply through equation 4. So multiply equation 4 by 2, right? If I multiply through equation 4 by 2, remember I'm going to get 2 multiplies this, so I'm going to get 2z, and then it's multiplied this one, so I'm going to get 2s cubed minus 4x in this case, and I'm going to call this one equation 6. Remember, now that we have 2z and 2z, we can then subtract them to get rid of z, and then we can focus on the x in this case, right? So we have equation 5 minus equation 6, right? Equation 5 minus equation 6, we have equation 5, which is this. So 2z minus 2z goes away to give us 0, and then we have 5x and then minus 4s, that will give us 9x, and then with the cube component we have negative s cubed minus 2s cubed, that will give us minus 3x cube in this case, right? So we have everything equals to 0. From here we have just our 3. I'm bringing everything to this side, so we have 3 cubed minus 9x being equal to 0, right? So now we'll go on and further simplify it over here. So let's further simplify it. Remember, we have 3s cubed minus 9x being equal to 0, right? So simplifying this, I can divide both sides by 3, all side by 3. This will get rid of that, this gets rid of that, it's left with 2. This goes to 0, so we have s cubed minus 2x being equal to 0 in this case, right? How do we solve this? So I have x here, I can factorize that one out, so I can have s squared minus 2 equal to 0 in this case. So in this case too, I have sorry, it's 3 cancel itself, 1 cancel here 3 times, so I have this to be 3, sorry. And then the first component is that s is equal to 0, and then in this component we have s squared minus 3 equal to 0. X here will be equal to the square root of 3, that is if I put square root on both sides. Square will cancel the square root, and I have x here to be equal to plus or minus the square root of 3. So realize that I've still gotten that in the first case I had s being equal to plus or minus 3, and I've gotten the same component on this side, right? So if that is the case, then this implies that our s values are just we have s equal to 0, and then s is equal to plus or minus the square root of 3, right? These are the possible values of x, y, and z that we can get. So in this case, the question says we should find s squared plus y squared plus z squared. Therefore, if you put everything into this equation, remember that if I have the square root of that, the squares here will get rid of the square root. So I'm just going to get 3 plus 3 plus 3, and this is just going to give me 9. In our first case we had 9, in our second case too we still add 9. So therefore everything is just equal to 9 in this case, right? So thank you very much for joining me in this section. I hope this section was interesting, and I'll see you in the next video. Thank you very much.